Guys, new stuff, new stuff, new stuff, new stuff. All right, so here, guys, so here we go. Let's just introduce this new idea. So the exterior. I'm so glad, Maya, that you asked that question about our homework because it leads right into our new stuff. Don't worry, we already did it. So let's talk a little bit about language, what it means to be not non-adjacent. What's the word adjacent mean? Mike? Do you agree? So next to. So basically what I'm trying to say here is that the exterior angle of a triangle, that the one outside, the one I labeled x, happens to always be equal to the sum of the two non-next to angles. Do you know how much x is? How much is it? It's 110. I can prove to you that it's always the case that this will exist. Does anybody want me to do that? Or you kind of get it? Yeah. I mean, it all comes from the fact that there can only be 180 degrees to a triangle. So if these two are locked in place, then this one must be locked in place, and these two form a linear pair, so that's locked in place as well. Let's play again, though. Let's play again. Right? Suppose I gave you a different drawing. And I label this 110. This is x, and this is 65. Do you know how much x is? Oh, it is the same. Oh, yeah. You're very good. Some people actually won't be able to notice that a rotation of the same shape doesn't change it. So how much is x? Yeah, x is 45. 110, the exterior angle, equals the sum of the two non-adjacent angles. So yeah, x is 45. Very cool. So we're going to get some more practice with this by doing the back of our homework sheet. Do you guys need me? Do you want to do some with me, or are you happy working on your own for about 10 minutes or so? Let's do one or two with me, and then we'll see what happens. I'd like to do crazy also new stuff, but you guys might revolt against me. I don't know. Maybe we can introduce some other new ideas, but let's see what happens. Let's try number 10. Number 10 on your homework sheet. Let me just draw a picture of it. Ah, yes. Well, this is a way more complicated example than the ones that I just gave you on your notes. But the ideas hold. This outside angle right here must be equal to this angle plus this angle, right? So 11x plus 2 has to equal 5x plus 10 plus 58. Well, we're going to do it real fast. 11x plus 2 has got to be equal to 5x plus 68. Let's move things back and forth real fast. 6x equals 66. X equals 11. So we didn't realize for our directions, for numbers 10 through, how many are on top up over there? 10 through 14, find x. And then in the ones after that, you have to find the angle, which means you're going to have to plug in. Do you want to do another one, or are you guys okay? So this is a packet to be completed. As soon as we finish the packet, then we can have our tests. And by no means would I ever make this homework over the weekend. I know, don't worry. We're going to do it one at a time. So the first thing that we're going to talk about is the idea of congruence. I kind of showed you the symbol before. Remember I told you we were going to come back to it? Now we're coming back. This symbol right over here is the congruent symbol. It's combination, equal and smiley. Not smiley, but like, yeah, like tilde. What's it mean to be similar? Mike. Natalie, is that what you're going to say? Same shape, but not the same size. It's like having a little itty-bitty circle. Oh, hello, little circle. And then having a circle the size of the world. Those two shapes are similar. Yeah, but I knew because you guys are the honors class, you would bring that up. Yeah, the circle is not, the world is not a circle. What is it? Oh, come on now. All right, okay. All right. To be honest with you, I am not. This ways to prove triangles congruent is for next week. This is for next week. This is for next week. But if you want to read through it and see what you're coming up to, then you are more than welcome. Open your packet to the first page. And all we're going to do is talk about a matter of formality. Stop talking for a minute so you can listen because not everybody will get this right away. Do you see how it says that these two triangles are congruent in the first one? You can't just write the letters however you want. Right? Be careful about that. You see, when you claim that two triangles are congruent, when you write them down, D has to be the angle that matches with K. E has to be the angle that matches with J. F has to be the angle that matches with I. And do you see how they label them up, these little markers? That's how you also have to label your triangles. Right? So now you can tell, right, which line segments are equal to each other. In the first triangle, FD, do you see it right here? FD? FD is opposite angle E. What angle matches up with E? Hannah? I mean, these two triangles are congruent, so that they are the same shape and the same size. I mean, they are perfectly equal to each other in every way, shape, or form. They're copies. So, Chima, J. Yeah, J, look, they're in the same spot here and here in the written portion. And on the diagram, although they might be like rotated, remember how I did that example? And Sam was like, it's the same image? They do that all the time. They just rotate and mess with things. J is the exact same. So Ki matches up. And that's the answer. Let me think about that for a minute. We really should have it to be matching perfectly, and I agree with that. It should be IK. I agree with that. Now, do you lose all your points for messing something up like that? I don't know. I think it's rather subjective, you know, but certainly when you write the triangles down like this, it's got to be perfect. All right. So we talked about that. Let's see what else. Let's try again. I don't know. Let's pick another one that doesn't have all the markings in it, like number 3. What? It talks about angle U. What angle does U match up with? Jenny? Yeah. Okay. My smartboard is absolutely working so ridiculously slowly. So do you get the idea, the point? Hold on one second.